All right, so this is lesson 5-3, medians and altitudes of triangles. We're going to apply properties of medians of a triangle. So a median of a triangle is a segment whose endpoints are at the vertex of the triangle. So here's a vertex, and here's a vertex, and here's a vertex, and at the midpoint of the opposite sides. So if we found the midpoint here, so those two are equal, then this would be my median. That is a median there in green. The centroid of the triangle is where all three medians meet in the same spot of a point of concurrency, so that is called the centroid. We're going to skip altitude and orthocenter. You're not going to be quizzed or tested on that, so just go ahead and skip that. So the centroid theorem is that the centroid is located 2/3 of the distance from each vertex to the midpoint of the opposite sides. So take out your compass and protractor. We're going to do another construction today. So I'm going to construct 3 perpendicular bisectors, not so that I can find the perpendicular bisector, but so that I can find the midpoints, because I use the midpoints to help find the centroid. So I'm going to have my arcs like so, just like I've done before. And this time, though, I'm not going to draw the perpendicular bisector. I'm just going to find the midpoint. So there's a midpoint there. And here's a midpoint here. And my last midpoint is right there. Okay, so now I'm going to go from that midpoint to the opposite vertex. So here's one centroid. Here's the next centroid. And here's the last centroid. And as you can see, they all meet in the same spot. This is the point of concurrency where the centroids meet. Now, the cool thing about this is that the centroid is located 2/3 of the way from the vertex to the opposite side. So I'm not going to use my protractor to measure. I'm just going to kind of pick some numbers out of the air. Let's say that this here is 10. Well, that's 2/3 of the way across. So if you think about it, this is separated into thirds. So here's your thirds. So if this whole thing is 10 here, then this piece has to be 5. Okay? And we also have thirds going across this way. So whenever you look at a centroid, you'll see that it's obvious there's a longer side, a longer piece, and a shorter piece. So the longer piece is the part that's divided in half, and then you have a shorter piece that is by itself. So these are my thirds, 1, 2, 3. So let's say that this one was 12 here, then I would know that this would be 6 there. Let's say that, oops, I forgot to do this in thirds. There we go. Let's say that I know that this one is, I don't know, 3. Then this one has to be double, which would be 6. Okay, so that's how we do the centroid. Like I said, we're not going to bother with the orthocenter. So if you take a look here, we're going to cross off orthocenter. The centroid is the point of concurrency of the centroids, which are a segment from the vertex to the opposite midpoint. And the centroids are always in the triangle. They'll never be on or out. Okay? And that's it. Thanks for watching.